This goes along with 7.3 activity 1. We will write a linear function that relates y to x. Now that new wording is a little bit different. So that is a key part of this lesson. So the directions say plot the points from the table in the coordinate plane. Write a linear equation for the function. So we know how to do the linear equation, which is y equals mx plus b, b, b. So when it says write a linear function that relates y to x, that is exactly the same thing. So this writing a linear equation, instead of equation, it could say function. Either of those are interchangeable. And instead of saying for the function, what I want you to do on your paper is to write relates y to x, because in tomorrow's homework you're going to see that wording. And when you see that wording, relates y to x, all you're going to do is write an equation y equals mx plus b. And we already know how to do that. So our first step is to plot the points, and our second step is to write that equation that relates y to x, which is y equals mx plus b, 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 b. And when we plot our y-intercept here, it is 150. Hey, that's what I need for my b, 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 b. So I'll put that in right now because I found my y-intercept. Bring down my y, bring down my equals, bring down my x. So now I just need to have my slope, but I still do have to plot my points. So my next point is 2, 125, 4, 100, 6, 75, and it sort of looks like it's going down 1, but remember, it's not down 1, it's down 25, because this is a 75 down to a 50. So we have to look at our scale, and it's down 25 and over 2. So I notice that it's going in a downward slope. So my slope will be negative for this one. So I want to make sure when I calculate my slope, it's going to be a negative slope. So I'm going to go to my numbers here because it's a little easier to see the actual slope here. I have a harder time with my graph. Not too bad, but I have to, it's kind of tricky sometimes with that scale. But if we do here with our numbers, here's our minus 25. Oh, I did a minus 2 up here. It should be a plus 2. I was negative happy. But it's a plus 2 to go up. And 150 to 125 is a minus 25. And that is a linear one. So here I'm going to use my slope, which is m equals the change in y over the change in x. I know we all know that now, but we're going to still write it so we get the right numbers in the right place. These two, which are on top, but it doesn't go on top of our slope, it goes the x's. So that 2 goes on the bottom because that's the change in x. The change in y is negative 25, so that goes on our top. And hey, there's our slope. Now, I know you feel like it's a little funny. You want to make it into an improper fraction or a mixed number, but we can just, because it's slope, we can just put it right in our equation. And that is, well, as long as our fraction is there's no common factors there, we are good to go. So here's our equation. Y equals negative 25 over 2 x plus 150. And again, that relates y to x right there. That is our equation that relates y to x. Now, if we take a look at b, we'll plot those points. So 4, 15, 6, oh, this is a little tricky. It goes up by 2s. It looks like it goes up by 4s, but it actually goes up by 2s. They just skipped writing those down. So 620, 825, 1030, and 1235. So it looks like it goes over 1, up 1, but remember we have to look at our scale. It's actually going up 2 on the x's and going up 5 on the y's. And it actually is a lot easier to see that here in our table. So when we go to our table, we have plus 20 or plus 5, plus 5 and plus 2. So my slope, which is the change in y over the change in x, equals 5, because that's our y, our change in y, over 2. So now that's going to go on our equation. To relate y to x is our equation, because it's in a straight line here, it has a constant rate of change, is y equals mx plus b, 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 and our 5/2 goes in for the slope, the m. We bring down the equals, bring down the y, bring down the x, and my y-intercept is, well, I could use either the graph to go down, I could go back on my equation or my table. That might be a nice way to do it too. But our other way is to calculate it. Remember, we can use 1 point to use in our equation. So I'm going to use this point right here, 4,5 or 415. And remember, x is 4 and y is 15. So I'll substitute the 4 in for x and the 15 in for y. Bring everything else down. So I'm going to multiply those two together and bring down my plus b. So now I'm solving for the y-intercept, which is our b. We're going to solve for b, which will be our y-intercept. So I'll simplify before multiplying. 2 goes into 2 once, 2 goes into 4 twice. I have 1's in the denominator, so that would be a denominator of 1. And we have 10. Bring down my plus b, bring down my equals 15. I'll subtract 10 from both sides to get b by itself. So b equals 5, which is my y-intercept. And I'll bring that back up to my equation and rewrite my equation. Y equals 5/2 x plus 5. So there is a linear function. And remember, it's a linear function because each of these points has exactly one output. So if we did that vertical line test like I showed, that's still, it is a function. We called it, it's also linear because it's in a line, so we could write that equation in slope-intercept form that relates y to x.